Hello, my name is Frank, I'm from Mindset team, and I'll show you results of our project for computer vision task for bicycles. So we have task understanding data extraction part of project annotation tool, Amazon recognition, PyTorch computer vision library, classification task, object detection task, segmentation task, and implementation of pilot project. So this is parts of our projects, and we are begin from data extraction. We use picture Google Grabber, where we can put different queries to Google, and then start Go, and it's going to download pictures from Google. So I just stop it for now, but you can see here we have different images from Google we already download. So it's electric bikes from different sources, different sites, and we are using that in our project. So first task was extract data for classification task, so we use that tools. The next part was to make annotation. Let me stop. Okay, after data extraction we do annotation, and for object detection and segmentation task we did annotation on CVAT tool, and let me show you how it's going. So we installed this CVAT tool on our server. Initially we downloaded it's open source tool for annotation, and we downloaded it from GitHub, computer vision annotation tool here, and see how to install. So we did that on our server, so we can see that we can do bounding box annotation, where we do boxes for it, and we have segmentation task where we can do segmentation annotation for it. Let's have a look how bounding box annotation looks like. So you see tires here and bounding box around, so different parts we discussed, and this annotation for 50 images for mountain bike, and 50 images for electric bike. The same annotation, but for segmentation task we do here also in CVAT tool. So let's have a look. You see that segmentation annotation is a little bit difficult and takes much more time than bounding box annotation, but because of much more dots you should put around the object you need to extract. And we also did that for 50 images. Then after that you can easily download it, dump annotation to any format. We use for segmentation mask zip and Coco.json one for bounding box for detection task, but you can use any of that. And after that we are going to learn our model, to build our model. So we did that in Jupyter Notebook, and after that we are going to normal IDEA. First task was classification task. Here you see we have 3 video cards on our server, but we have 6 actually, but for that project we use 3, and we import libraries, and PyTorch Vision is one of the most important libraries here, and multiprocessing pool was good for library for augmentation task, where we need to increase number of pictures we use here. After that, we created a dataset class. Object of that class contains all images and targets we can put to our model and start to learn. So we have different preparations here. Just checking that load our images exactly what we want, and then we start learn. So we used net 101 for classification task with two classes at the final, and you see that validation accuracy for SGT classifier is about 85%, and if we change that for Adam optimization, you can find more general lower part of function and more general minimal function, and so we get better result. You can see that we can put our image, get actual label. It's for validation part of dataset, and get results is relatively good. We have here different metrics, and you see that for validation task it's have a lot of right answers. So in the corners upper left and down right, it's right answers, and here's mistakes. But for and it's for 3 epoch, and we can increase number of epochs and make it better. So better model will go into Telegram bot. So now detection task. Detection is bounding boxes around objects we need. Also we build dataset class reader with getItem method for PyTorch. We read the bounding boxes, we read areas, labels, and put that into model. Just read labels, and then we initialize our model. Here it's ResNet 50, and it's a bounding box predictor here for detection task. And we learn our models. The process of learning, it takes about 1-2 hours for 50 images on our video cards, and we see results. So we just put test images and get the result. That seat tires, it's finding quite good. And here we show only good predictions, but also model can get bad score prediction, also can show you, but here model is quite strong for that objects, but for other projects or other details of bicycles it's not quite strong, but we also can put it here. You see here found so here model found battery. Here also no, it's wrong fork, it seems. So wrong fork also can be a problem for some bicycles. Okay, next task will be segmentation task. After detection, for segmentation task we also did augmentation, where we increase number of images, and let me show you how augmentation looks like. So initially we just take one image and create for one image additional 10. So, and that's 10, it's resize, mirroring, noises and other parts to increase quality of model. That model after that augmentation task is understand what possibilities can be with bicycles and quality increase. So just save that data set, and after that we can use that data set in our model. Also build a class for reading that data, and let me show you results. Just read our objects, our segments for the model to check that they are okay, what we are going to learn. This is our pilot examples. And let me show you. So here also a learning process. It's about also 1-2 hours to get for all 500 images, and finally we get results where we have model and we have prediction. So prediction looks like that. We put image and extract exactly what class we need by pixels. So here's chainrings, here's seat, here's a wrong fork, tires of bicycle, and we extract exactly that part. After that we can put that part to another model, for example regression model for pricing each part, or we can classify each part what it is, and data from for classification we have also from the web, and this will be next part of the project. So now we have 3 models: classification, detection, and segmentation, and next part will be implementation that in REST API, and connect that REST API to Telegram bot or web, to any site, and also we will show you that soon.